Okay, now this is the very last video. Okay, so take notes 8.3 part 2. And in this section, we are going to cover de Moivre's theorem. Okay? All right, so de Moivre's theorem. And we use this theorem when we are doing higher powers of complex numbers written in trig form. Okay, so if z equals r cosine theta plus I sine theta. So this is trig form of a complex number. And suppose n is going to be our exponent. So n is an integer. Okay. Then z to the n is going to equal. So we would take this whole complex number written in trig form, right? Cosine theta plus I sine theta. And we would raise the whole thing to n, right? And what happens is de Moivre's theorem says, okay, well, when you do this, all you have to do is do r to the nth, and then over here you will be doing cosine n theta plus I sine n theta, and that's it. Okay. If you want to use the short version of writing this, that's fine. The short version of writing this would be r to the n cis n theta. Okay. All right, so let's take a look at an example here. All right, let's find 4 cis 145 degrees to the third power. Okay, so 4 cis 145 to the third power is, according to de Moivre's theorem, it's going to be 4 to the third power cis 3 times 145 degrees. Okay, 4 to the third power is 64. And 3 times 145. So this over here turns out to be 435 degrees, right? But if you remember the argument of z should be the smallest, should be smallest positive angle, right? So therefore, and we know that anything beyond 360, from 360 on, is coterminal with an angle that's between 0 and 360, right? So let's put that, i.e. less than 360. Okay, so let's take that 435 degrees. Let's minus 360 to get the coterminal angle. The coterminal angle is 75. So here, the answer would be 64 cis 75 degrees, because we want the smallest positive angle. So it should be somewhere between 0 and 360. All right, let's try this one. Let's find 2 cis 40 degrees to the fourth power. Okay, so 2 cis 40 degrees to the fourth power, 2 to the fourth, cis 4 times 40. Okay, 2 to the fourth is 16. Cis 4 times 40 is 160 degrees. That's between 0 and 360, so that one is perfectly fine. Okay, suppose you need to find this. 1 plus I to the 10th power. Okay, so that would be absolutely no fun to do in standard form. Okay, so what you want to do first is rewrite in trig form. Okay. All right. So let's go ahead and graph this. So that's 1, 1. Okay. So let's find the r. That's 1. That's 1. So r squared equals to 1 squared plus 1 squared. R equals to the square root of 1 plus 1. So r equals the square root of 2. Theta equals tangent inverse of 1 over 1. We have that one memorized. Theta equals tangent inverse of 1, and that happens at 45 degrees. Okay. All right, so we can write the trig form of that complex number. So z is now square root 2 cis 45 degrees. Okay, so if I want to do 10th power, okay, so z to the 10th power, so that's square root 2 cis 45 degrees to the 10th power. Okay, so we get, what do we get here? So this becomes square root 2 to the 10th cis 10 times 45. Now, square root 2 is 2 to the 1/2, right? And then this is going to be 450 degrees. Remember, arg z has to be less than 360. Okay, so let's do 450 degrees minus 360 degrees. And that will give us 90 degrees. Okay, so this is going to give me 10 times 1/2, right? Right here, we're going to do this multiplication. 1/2 times 10 is 5. So that is going to be 2 to the 5th cis 90 degrees. Okay. 2 to the 5th is 32. Okay, so this is one way to write the answer. If they want you to write your answer in standard form, then you can just work this out. 32 times cosine 90 plus I sine 32I sine 90. Okay, so cosine 90. What's cosine 90? Cosine 90 is 0. And then here, sine of 90 is 1. So then we just get 32I. Okay, so this is trig form. This is standard form of your answer. Okay, so that's all there is to it. Might have to do a little bit of simplifying here with your exponents. Just remember, square roots are exponents of 1/2. Okay, so that's how I got this. I can rewrite the square root as a rational exponent. Okay, and then just keep in mind over here, your angle should be less than 360. Okay, all right, so that is it. I hope you all had a wonderful semester. Maybe one day we will meet.